All right, here we are for week 16 of the Kotlin and Architect project, building the GDAX app. Let's take a quick second to check out what we have been trying to build in these 16 weeks. It's going to tell me to refresh the page here, so we'll do that. And here we see a page where people can buy and sell Ethereum tokens for US dollars. And on the top, we see a bunch of people trying to buy, and on the bottom we see, or rather sell, and on the bottom we see a bunch of people trying to buy certain amounts, various prices. When they agree, we get a line over here in the trade history, and in the middle we have a price chart. And we have tried to build this as an app because they have a very, very good API and a big API reference page that gives us all the information we need to break this down and turn their data into a UI. So let's see if that's running now. There it goes. So when the app first starts up, it doesn't show anything. Or it might show some trades briefly, but then it's going to clear its whole history and start fresh. So it looks like we've just cleared the history. We're starting fresh. And there, we're getting all the data. And days like this where it's where there's a lot of movement going on, there's a ton of things, and you get a warning like this one, partially degraded service. What that means is that this is probably not going to match up with this. Now, it's going to match up, like we'll see this 23442 is right here, but see it's like maybe 20 seconds behind. So we've got 10:02:20, 10:02:41. So it's a little difficult to manually check these on a busy day, just because that's, we get slower service. Then we've got these three tabs at the bottom. So we start on the trade history tab, then we switch to the order book tab, which shows this section over here. Assuming that works, let's try coming back. There's the order book. And we've got this as a recycler view, which starts at the middle, or tries to start at the middle. But so we could scroll all the way up here and see all this red stuff, and scroll down to see all this green stuff. And then in the middle, we've got the price chart tab, which shows the price chart. And it's got labels, and we can change it from 15-minute candles to hour candles. Or wait, it was set to, it was hour, so that looks like a bug. We've got hour, and then 15 minutes there, and then 6 hours. So this is saying the width of each of these sections, these little candles, is summarizing a 6-hour segment of time. So you'll see this goes all the way back to August 30th when we put it on 6 hours per candle. But if we go to 1 hour per candle, it only goes back to September 11th. And we've got that all done. And actually that was done at the last video. It kind of cut out on me, so we didn't get that on screen. So let me show how that's done. Actually, let's check if there's questions first. Anything going on? Cool, perfect. So to see how we did that, we added a spinner. Right, where is the spinner? Right here. We added a spinner inside the toolbar. So let's look here. We've got the toolbar, and we added a spinner to it. And on that spinner, we create an array of choices. So there's our choices right there. Then we create an array adapter for our spinner using the layout that we have set and our choices array. And if we look at this layout, spinner item, we did end up having to create our own layouts for this. And most of the examples, they'll have you use the Android standard layouts, but that was not giving us the ability to set the text color to white, which is what we needed. So we did that with our own layout. And we did the same thing with the spinner drop-down item. The drop-down item of a spinner is this bit right here. So these are actually two separate views. There's this view on the top of the spinner, and then there's this view, which is the drop-down layout. So we have to specify those. Then we specify the drop-down resource. Then we set the adapter of our spinner to the spinner array adapter, set the background color to white, and set up a listener. Then inside that listener, we do an on item selected, and depending on which item was selected, we set the granularity and reset our candles with that granularity. And that takes in, so 15 times 60, that's taking in seconds. So we get our chart view by reaching through our chart fragment and then calling reset candles, which takes in the granularity, makes that the new API endpoint, hits the endpoint with the get statement, gets the result, gets candles from that result, and then invalidates the UI. And remember, invalidating the UI makes it so that the UI is going to redraw itself. So we let the UI know it's wrong. It redraws itself using our new candles down here in the onDraw function, which we did finish on the video, but let's go through it very quickly here. So if there are candles, we're only going to take 60 of them, no matter how many it returns, and that's only because we get 60 on this screen, so it's nice to match the UI here. So for example, if we have 15-minute candles here, and we go to 15-minute candles here, it looks exactly the same. And if we rotate it, we do have this saving state as well, and let's show that really quick. So when we, where is it, right here, reset candles, so we have selected granularity ID as a field, or since we're in Kotlin, it's really a property of our main activity, and we start it at 0, and then when we select a different granularity, we set that property, and then in the onSave instance state, we save that property out to a granularity bundle, or to a bundle under the key of granularity, then we retrieve it, and on restore instance state, and we set it the selection of our spinner. So saving, restoring instance, and yeah, so that looks like this, which is perfect. And let's see if we can get that bug to happen. Maybe how did we get that? We were on like an hour. No, we were on 15 and it started as an hour because it didn't have, actually, what did we have? It started like that, and then we started it fresh. So let's come in here and we can find it. Oop, that's not right. We can grab this GDAX app, open it, and see it does start. If we closed it, this should all go away. We'll see. Or maybe it didn't kill the process because we didn't actually have it closed long enough. Either way, we're on this tab. So 15 minutes, that matches. Okay, so we'll leave that one alone. See if we can't figure it out later on. But there's one thing that I want to look at right now, and that is, so at the end of this, we are going to finish the project today. So at the end, we'll try to get a whole overview of what the app is and how every single one of these pieces fits into it. And that'll probably take the last, I don't know, half hour to an hour. But until we get there, one thing I want to look at is this, what we're missing, and it's not necessary, but you'd want to do it. It's not in data. It would be a view model for our chart fragment. So here we have chart fragment, and similarly, we have an open orders fragment and our trade history fragment, and both of those have view models to go with them. So let's come into our chart fragment and notice that all it does is set a chart view. So let's find chart view. And in here, let's see if we can show the issue. So reset candles is the only point where we make an API call. So let's come in here and say, we're going to log API call and log the granularity. And then we're going to run the app. And we'll see if we're going to have a good day of app running. Sometimes we've had this take up to a minute to run Gradle, which is okay. It just means I need to be aware of that and be able to show something else going on while that builds. And since it looks like that's going to be the case, let's go look back in here. And what we're trying to find out really is if we're calling this with the same granularity twice when we rotate the device. So if we're calling this with 60 minutes, which would show up as 3,600 seconds initially, then we rotate the device and it shows up as 3,600 seconds. Again, we're doing 2 API calls on a rotation, and we should be saving that state. We should be saving these candles as part of the view model, or really as the view model for our chart view fragment, or really chart view. So I'm pretty sure we're gonna have to do that. So we can start doing that. Oh, and did we build finally? There we go. Okay, so price chart, come into logcat, put in a backtick because that's what we have in the E method to help find and stop searching for candles and pick an emulator that is alive. There we go. Yikes, maker order is null. We don't, that's not useful. Okay, let's find that log message. Control Shift F, maker is maker order, sorry. There we go. And let's get rid of this message because it looks like that happens fairly frequently. Not sure why it's there we go. All right, then we'll hit run, see if it'll go quickly. But in the meantime, we were working on getting a view model set up for our chart fragment / chart view. So let's look at trade history view model, and let me close some of these other sections. Okay, let's just go into this and start making what we need, or what we think we need. Chart view model. It's going to be a class. We're going to add it to get, and let's split this one vertically so we can see two things at a time, and then hide this. And that looks fine. And this is going to extend Android view model. And the difference between Android view model and view model is that Android view model has access to a context, which is what allows us to use, I believe, the database here. All right, so we need to make this take in an app. Which is an application, which we need to import. There we go. And then we need to pass that in there because it takes on an app. And what's kind of interesting to me about that is one way you could save the state of the candles would just be to have the candles array exist as a variable outside of the class or attached to the app right here. And you can make that something that you can access statically, like we've done with this DB object. So this DB object, we're gonna need a little more room to see everything. When we create the application, we create this temp DB object, which has to start as null, because in Kotlin you can't just set it to something. We have to wait for onCreate before we can set something. But when the app is created, it has to be set to something, which is why it has to start as null. So we get temp DB, start it to null, set it up to be an actual DB, and then by lazy, what this means is that the first time DB is accessed or we try to use it, that's when we're going to evaluate it, which lets us say that temp DB will not be null because we're going to access this after we've set up temp DB. And by having this outside of our app class, it means that we can use DB anywhere we want. We can just use it. It's just available. So that's really helpful. And so that's what I think is going on with having to pass the app class in here. Is it's just a way to give us access to things permanently. And I guess the Android team thinks it's messy to keep things in the app class, and I might agree. So in here we're going to want candles, val candles, and this is going to be a live data of a list of candle, which we can import, and we can import live data too, equals mutable live data of that type. All right, let's just copy this part. And we can copy over match order with candle. So we've copied all of that. So this is a little difficult to see. So do not import match order, then close this. And we want to say candle. And make this candle as well. And all right, that has ran now. So let's go to not logcat. Or no, it is logcat. So we'll see price chart, API call 3600 and then 900. That's interesting. And if we rotate it, we get both API calls again. So, yep, that's the issue. We are getting the 3600 call is coming from trade history view model, or not trade history, chart view. And when we get a new chart view, we call reset candles. But we might have candles from view model. So if we can figure out how to get this involved, this view model, then we're in a good spot. So next we need to get our view model attached. So let's open trade history fragment to see how that's done. Like that. So let's grab view model here and put it in chart fragment. We'll get our new view model. Yep, and we don't want the trade history view model, we want the chart view model. And then view model dot candles. We would want to get our chart view dot candles equals view model dot candles. Is essentially what we're trying to do here. Though I don't know if we can use LiveData in the same way that we're using it here, because it's less of an observe sort of thing and more of a just it is what it is until they've picked a different time frame. We're not going to be trying to update it as we go. So if we sat and watched the app for an hour, we're not going to draw more candles at that time. We're going to leave it as this because people aren't going to sit here and watch the app for an hour. We don't need to handle that case. Okay, so let's try maybe just not doing a live data. Let's just do a list of candles. We'll need to get rid of those other brackets. And we need to make it an empty list. There we go. Actually, can we let's make this a mutable list. Mutable list, should be able to leave it at that. And then it'll be mutable list of, so mutable LO. All right. Field.value is now not a thing. Okay, because it's a list, so it doesn't have that. So we can even get rid of that. I'm wondering, can we just do that? Sure, let's try it. So val candles and chart view model. So we'll try just saving to that thing and see what that does. So init if candles mutable list of candle. That's what candles is in here. This finds a list but requires a mutable list. So then we do to what am I missing here? Sorry, doing that at the wrong point. So there we go, to mutable list. And then we have our candles. So if candles is dot is empty. Then reset candles, and we should pass in context. Can we get access to this from, yeah, let's also pass in the view model context and view model, and then we can alt enter to add this parameter to the constructor and refactor. Yep, change signature, that's fine. And if we pop over to chart view after having done that, we now have view model. So what we want to do is call whenever reset candles is called, we want viewModel.candles. We're going to try just using viewModel as our data source instead of this. So let's get rid of that entirely. Now viewModel.candles. Perfect. .candles. So then if we want to reset candles, our view model, what's happening here is that our view model.candles is a val and can't be assigned to anything. But since it's a mutable list, one thing we can do is view model.candles, and it's a little weird to be hitting that. Feels strange to hit it so much right here, and we could even pull this into there. That would be interesting. ViewModel.candles equals, or not equals rather, but we can clear it, and then we can say .add all, and then I'm pretty sure we don't even have to cast it to a mutable list. Yeah, so that works too. We'll clear the candles and then add all the candles, and then it here. Why are you having issues? What's your problem? Must be viewModel.candles, so let's get that in there. And does that make everybody happy? Okay. I wonder if that did it. Let's find out. So we're running the app. We're going to see if rotating the device still sets off 2 reset candles calls. So hopefully it'll be missing this call and will include this call, which we might be able to get rid of. We might be able to get rid of the call and main activity for that. Right, we don't need to set that anymore. All good. Get that. Yep, run it. See if there's any questions. Cool. All right, so that's running. And looks like it's just finished building, so it should be, yep, there it is. And let's pop in logcat. Give me that one and this one, and then we are going to price chart 2 calls because it was empty at 3,600 and then 900. I wonder where that one's coming from. Let's get into the app, and we will go to chart view, and we're gonna get reset candles, Command B. So it's not that one, it's gotta be this one. So the spinner selected is getting called with 0. That's right, because spinners get called like that. That's a very frustrating bug. So there's not much you can do to stop spinners from selecting that, and let's get a quick search on that. So spinner don't select automatically, or spinner automatically selects first item maybe, or spinner selects first item, pretty sure. Yeah. Spinners get selected when you start the app. That's just a thing that happens, and it's a frustrating thing. So, but I think we should still be able to test that we have, pull up logcat, missed the other issue. So rotate 3600, 900. All right, that's much better. Because last time we had two 3600 calls, so, so 3 total calls, and now 2 calls, better than 1, or better than 3. All right, let's rotate back. See, we got 3600, 900, which is strange. Let's figure out which of those is getting called. So we can come into main activity and put in an on item selected. So E item selected position, and then in chart view, get back in there. We can log candles are empty or is empty. Then we can run this, and that'll let us know what the issue is with our candles. So why are we seeing 2 calls instead of 1? Ideally we'd like 0, but all right, launching logcat. Price chart 3600. So candles is empty, call 3600. Item selected is 0, call 900. And then rotate. And this is from 1028, which is what time it is. It's also from 1028. So that's 2 candles is empty calls. All right, so we are missing something with our data not being saved or restored. Let's see, so let's go. There's a separate issue, so we'll leave that tab open. Save Android view model. Reference. Let's see if that's, no, that's probably the right one. So a view model handles, view model is always created in association with scope, will be retained as long as the scope is alive. If it is an activity until it is finished, okay. Okay, so view model is only responsible for managing data and should never access your view hierarchy. We knew that. However, we're trying to avoid using LiveData and an observer because we're not actually saving the data off into a database like we are with the other stuff. And we'd like to not save it off to a database. And we really could put it in a bundle. That wouldn't be difficult. It's only 60 data points. Let's see. So let's investigate our view model here. We can Control O. We have on cleared and get application. but we can't figure out, okay, so let's put in a getter for this. We'll add get and brackets, and it'll return mutable list of, which is correct. What are you complaining about? Oh, you actually need a return. Okay. And we will also log new candles. And this will tell us when our chart view is being accessed to give us new candles. And hopefully that can shed some light on what's going on here. Loaded trade history, all right. And price chart. What? That's a lot of new candles calls. Oh, that could be, that's an issue. So let's try and copy this. So every time, I mean, this was bound to fail, obvious. It's obvious in retrospect, but every time we call or reference our candles array, it's going to use our getter to get it. So obviously we're going to return an empty list every single time that we referred to this, which is why we got more than one call, or more than two. We got 5 or 6. So let's try to copy the logic from here. So if field is empty, yeah, okay. So if field is empty, then we need to set it. Field is empty, then set it. Not entirely sure how this is going to work. Set it, and otherwise just return field, right? Yep. Okay, so return field. Okay, and then there we need to set field to something. Perhaps, yes. Because, so this could be field equals mutable list of. And then what are you complaining about? There's no way for that not to be initialized. Okay, so equals mutable list of, we can initialize it, and then every other time we get it, it'll be, yeah, we'll have to put some log statements in here to see what's going on. So if candles is empty, then we want to get the data, but it's not going to save it for us. So if field is empty, all right, let's go back to this one. So if the field is null, then we're going to set it equal to something from the database. So we'd like to avoid using the database because this data is not necessarily database worthy, though I guess that doesn't mean the other data is, but taking a different approach. All right, so we'll set that equal to that. And let's go with this. We'll just log it and see what happens. So e get candles, and then we'll also log if it was empty. Candles was empty. And we'll see how many times candles was empty is called. Because we're going to, oh, wait a minute. No, yeah, because it should not be empty after we've put candles in it, which happens after chart view, reset candles, should be adding candles. Let's find out. All right, trade history page, price chart. Get candles was empty. Get candles. Get candles. Okay, so there, get candles had some data in it. Clearly, because we're seeing data, so that's good. And if we rotate, we see get candles. Get candles. Candles was empty. I wonder why it is then empty there. And that's right after it called a loaded trade history too. So it's like, does that get called here? It seems that that might be called on the rotate, but I'm not entirely sure why. Because we want this to just not be empty. Let's go back here and see if we can find using view model to persist Android or Android. Which of these is going to be a good one? So we need to find, yes, so here it's going to tell us that view models are for use when you have larger data, and that you would use save instance state or on save instance state. And yeah, here we go. Yeah, so on save instance state is for saving small little things, and view models are for persisting something bigger, like our chart. All right. Come on, give us some code down here. Ugh, no code. View model, persist, Android. Actually, we can narrow this down by typing site : Stack Overflow, which is going to limit us to only Stack Overflow. StackOverflow.com. And we're going to need to put in the word Android because we're getting some C# answers there. Let's see. All right. Nope, we need code. That was from 2015. No, that's another thing we should narrow down by. We can go into time and do past year because it's definitely only the past year. Really the past 6 months. So our view model doesn't seem to be persisting as well as it should be. And we don't have any lifecycle methods we can really use to make it persist. So let's look at the view model docs. Is this what we're looking for? Because we want to try and find if, yeah, that's exactly what we're trying to do. Store and manage UI related data so that the data survives configuration changes such as screen rotations. Perfect. Load users. Yeah, but see, we don't. How would we get the data into our view model? Okay, we can try and adapt this. All right, let's take this page. I think I can. We'll get this. All right, so now we want candles to be a mutable live data of list of candle. and we're going to have to start it as something. So just copy this one, and actually we can bring this over to about there. So copy, paste, don't import match order. We want this to be candle. All right, then when we get it, we want to if field is null. That's not how you'd write it though, is it? Equals null. Dude, dot is null. No. If field is null. Yes, that is always false. Field.value. So presumably LiveData contains a value object. So field.value is null. Then we set that would be the candles, so that would be field equals mutable LiveData. Yeah. And then we would load users. Well, not load users, but load chart. Create function. Function load chart, and this will be candles. Get users. Do async operation to fetch users. It's very common that two or more fragments in activity may need to communicate with each other. This is never trivial, as both fragments need to define some interface description, blah, blah, blah. Common pain point can be addressed by using viewModel objects. Imagine a common case of master detail fragments, where we have a fragment in which the user selects an item from a list and another fragment that displays the contents of the selected item. These fragments can share a viewModel using their activity scope to handle this communication. Okay, this looks like a real small MVP. This is nice, I hope. Let's go with this. So we have immutable LiveData of a thing. We call it something, set it equal. Then we call set value. Okay, I like that. I like that. All right, so private fun, or rather public, or just function. Set value, and then here we'll say our, okay, so we want now mutable LiveData, which is a list of candles. Yep, so that's also correct. And then here, the get selected, we just return LiveData of the item, so we just return this, so there's no reason to have a get, basically. Okay, and then set value, we do candles.value equals, and we need a list of candles here, so list of candle, and we call it candles, or new candles, and new candles. And then to set it, we need to call select on our view model. So let's go into chart view and view model. Yep, that's right. Be upset view model. This is view model dot set value. New candles, perfect. And up here, we just want to call, do we just want to call reset candles? No, we want to say if viewModel dot, dot candles dot value dot is empty, or null. This is a Boolean question mark. Dot is empty or null. Come on. Is null. Let's see if there's a null thing. What was that? There was get or null. Oh, that's interesting. You can grab a specific position or null in case the position doesn't exist. That's cool. Is empty. Well, we can just check equals null, or it's a little longer than I'd like it to be. Candles dot value dot is empty, and that'll work, right? Except we need to use the right or keyword. View model property that could have been changed by this time. No, it's not by there. So, all right, only if it's null or empty will we call reset candles, which will set the value. And we'll have the view model from candles. And then down here we have view model dot not candles. Or no, it is candles. Dot value now. Which is that really what we do? No. Now you observe it. How do we draw inside of an observation? This is, so if view model, or not if, let's just try and look at it. So view model dot candles dot observe lifecycle owner get fragment. Okay, so we would need to do this outside in the fragment, I believe. So chart fragment, let's pop out here, and we will do view model dot candles dot observe, and we'll observe on this, and then we need a function. Required an observer of a list of candles, and we're giving it a function that gives back unit. Wait a minute, what? So observer this, because it's a lifecycle fragment, it requires an observer of list of candle. Item, does this, what do we do in the trade history fragment? Oh, we use the word observer. Okay, we create a new observer object. I mean, I guess that's true. That's what it had to be. I wonder why that's not the case in the Java side of things. Observer. Ah, nope, not OS. Observer. There we go. Then in here, it is a list of candles. So we do chart view dot reset candles, and now we're passing in the candles. Okay. And let's assert that it's not null, because that makes sense. And now we don't call reset candles here at all. Candles now takes in the actual candles as a parameter. Wait, then how do we get the granularity right? No, that can't work. Okay, so we've got viewModel.candles.observe. We're going to call reset candles on it or with it. Or maybe we just need to go back to using chart view having its own set of candles. Let's maybe do that. And then when we call reset candles is when we'll still set the candles, maybe? Or let's pull this bit into our chart fragment, or not chart fragment, chart view model. Because we need that other section, yes, that gets selected, where we get the candles, or no, rather, it stays selected, right? Because we call select, we call the thing, yeah, okay. All right, chart view, how are we gonna get this? Reset candles is going to call this function right here, which is going to take, which currently takes in granularity and calls through to the API endpoint to get the candles we actually need. So now we need this to be called every time the user selects something on the selector or when the app is first started, it needs to be called one time. So let's see. I don't think there's an easy way to get this done. Let's just Control Z. Yep, Control Z. Okay, that's as far back as it'll let me go, so let's get, this was candles. And then let's not pass in our view model. Let's get rid of the view model. All right, get that done. Run this again, see if it still works. We'll try to get this set up in a separate project here. See if it actually works for us, because it looks like it's not necessarily going to work, at least quickly and easily, getting it set up in this very large project. So let's go Android Studio, File, New project. View model MVP. And you know what, we can bump this up to probably 22. And let's see, that's 62.6, wow. You can really go to 19 now, that's awesome. We'll just pick that one. Empty activity is fine. Activity, yep, cool. And app. That looks good. I mean, it's the hour chart, or no, it's not. Cool. 6 hours. Show me a day. Wow, still up on the daily chart. Looking pretty bad on all the other ones, though. All right, trade history section still works. Everything's good. Right on. Let's see if there's any questions going on. There we go. Cool. All right, back to the app. Great, there we go. And we should quickly go check here. There is so we need to follow these steps first. And then here, so we want the Gradle for the project. GA center, we want to put in that guy. Then we want to copy these 3 lines. Put those in this build.gradle file. How do we have a... Well, don't target that one then. Target 25. All right, then we got that in there. We should be able to pop in their example from here. All right, if that doesn't want to play nice either, we might just skip to going over the app because it's pretty well finished. All right, yeah, that's looking like more trouble than it's worth. But rest assured, it looks like you can use a view model to save data easily, maybe. You know what? Actually, let's do that my way. Let's do it my way. So we're going to take this candles variable right here. And we're just going to paste it inside our app class. And now, back where we were. Nope, nope. Chart view model. Don't need you. You were confusing. Don't have time for that. All right, chart view candles is now app.candles or app.companion.candles. So companion is basically your static, except Kotlin doesn't have static, so if you sort of a static variable section, if you will. And I believe you can you put functions here? Fun x equals 2. Yep, sure can. All right, so we got candles there. Starts out as an empty set of candles. Then when this is called, if candles is empty, we do that. Otherwise, we set it up. And if it's, yep. All right, so that, let's see if that worked. All right, price chart. And we need logcat up here. We need to be near the bottom. And we got our 2 API calls. Remember, we're always going to get that darn 900 because of the spinner. And let's get this one up, and we're going to rotate it. And look at that, we just got the 900 call. So just got the call for the spinner, which, remember, if we change this to 6 hours and then rotate the device, and that's going to set it to 21,600. Then we rotate the device, we get just that 21,600. So that's just, we're just saving the spinner there. Just calls that selected item. So that's pretty good. You know, we're not, it calls the spinner, which it needs to do because the spinner is not saved. So for example, if we want to, we could maybe get away with only loading the data one time. So not having it call this when we rotate it. See, this is sort of a waste that we're going to call the API there, have it load the data just for rotation because we have that data, it's being persisted. So it's a little frustrating. But to handle this guy on item selected listener, we need to, oh, you know what, maybe we can get around this. But what the issue is this. Let's, oh, we're not scrolled to the left. That's what's looking, why it's looking funny there. We get this on save instance state with our granularity, and then when we restore instance state, for example, on the rotation, we're calling spinner.setSelection with, say, that 60-minute granularity, and then it's calling through here to reset candles. So how about we only reset candles if the can we figure out the granularity from, yeah, what if we pulled the granularity out as well into the app? So again, pulling things into the app like this, a little bit messy, but select a granularity ID equals 0. Main activity. Selected granularity ID goes away. Then we can import it. Oh, but we might now just have that issue with the selector. So actually that's how we can get around that issue. So if, but let's show that issue first, because I think it's an issue. What issue are you pointing at? Yeah, that's not a problem. Not a problem. Okay. All right, so we got rid of selected granularity ID. We pulled that into, oh, no, don't run. So now we don't want to save it either. We want to get rid of granularity here. We don't want to call spinner, or do we? Because when it restarts, when it refreshes the page, we will need to actually call that. So might as well still save it as instance state, which is weird because we have access to it. So no, we don't need to save it. We can just use it. So don't save it, just use it because it'll be saved and rotation just by the fact of it's stored in our app class, and the app class did not die. So we'll set selection. And then at this point, if we run it, it should still work. We've just pulled the selected granularity ID into our app class, and it exists here instead of being something that we are persisting through normal channels of on save instance state and on restore instance state. So we're just persisting it in the app class. Should be alive for the life of the app, which is all you need it for. So that should be good. All right, here's the app. Trade history, price chart, 15 minutes, and we rotate, and today is 15 minutes, and we put it to 6 hours. Different chart, rotate it, stays 6 hours, but 21,600, and if we rotate it back, 21,600 again. So we're saving the spot, but we're still redoing it. But what's nice is now we've got this saved off. It's just available. Well, to be fair, we are importing it. So selected granularity ID. So if selected granularity ID is different, so not equal to position, then do this stuff. So only do this stuff if we're picking a different one. Okay, so we run this now. So cool. Price chart and 15 minutes. Change to 6 hours. And let's watch the logcat here. So there's our 2600 from putting it to 6 hours. And you know, it starts at 15. It starts at 60 minutes, but it says 15 minutes. So let's make it match what it says by putting that to 15. Not a big issue. We're not going to run it again for that. But here's our 21600 from making it say 6 hours. Let's rotate the device and see what happens. Didn't load it again. So there we go. We have successfully succeeded at not loading the data twice. And we didn't have to use a view model to do it. We just put the data in the app class. So that's a very easy solution, and one that I like a lot. Though I'm not sure why it's not more popular. All right, so that saves off that data, keeps us from reloading everything. We've got it so that it should match now. That when we run this, it'll say 15 minutes and also show 15 minutes. And we've gotten around the issue of the spinner starting with a selection. So when the activity starts, when it first creates the spinner comes into existence and it calls on item selected on the first item, which is okay. There are pros and cons to that, but it's something we have to deal with. And we deal with it by just not doing anything if it's a different, or if it's the same one. So if we're already at 15-minute position and we load the app and it's like, hey, 15 minutes, great, select. We're gonna say, okay, but we're not gonna do anything with that. And that'll save us from getting those calls. So we've now gone from 3 calls to 2 calls to 1 call to no calls. Or actually, I think we skipped 1 call, but we've gone to no calls on a rotation of the device, which is really good. So we're saving like over half of our API calls. Really good stuff. So there's 15 minutes, there's an hour, there's 6 hours, there's a day. Pretty crazy last couple of weeks there, or a week maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Nope, 2 weeks, right about exactly. And still up from where it was before. Crazy. All right, put that back to an hour. What do we think should be the default screen here? Should it really be trade history? I think it should be price chart. Let's make it price chart. So change the default screen. We need to, in main activity, just at the bottom, we say switch fragment. Let's switch it to, and our fragments are up here, switch it to price chart by putting it to a 1. Now when we run it, it should start with price chart. Yeah, hey Toast, we are building this. So it's an app to represent buying and selling of Ethereum tokens. So these are all people, this is happening real time right now. These are people who want to sell Ethereum tokens for what price they want to sell them for. So this is their amount, this is the price they want to sell them at. And we've got people who want to buy certain amounts at a price. When they agree, we get an entry over here in the trade history, and we've got a price chart in the middle. So all of this data from this GDAX website, which is the company that hosts this, is available by an API. And for this project, we turn that into this app. So there we go. We started it again, and we got the price chart page as the front of the app, which is what we were looking for right there. Great. So we got price chart. We've got the order book section. And let's get these up. So come back to the order book, see if it loads. There it goes. So see, we've got the order book and matches this section over here. And we've got the trade history, which matches this section over here. And we've got the price chart, which matches the middle. And if we rotate it, and this is on 15 minutes, and put it on 15 minutes, and we see the same thing. So pretty cool. And one thing I do want to point out is if we click here to check the status page, we're going to see that we've got some issues. So I think that whenever they're having some issues go on, we see a little slower activity on the app. So to show that, we can look, this says 11/12/03. This says, well, there it's caught up, but just a little bit behind. There we go, 15, and we're still on 10 here. So we're not quite as caught up to the real time as we are over here, but we're pretty close. All right, so that's the app. This is considered, I think, about finished at this point. There, you could always add more. There's more you can do to any app, but let's take a look at this one and how it all came together. So to tell the story of this app, the first thing we did was we created this trade history page. And to create that, we needed first a bunch of data. So I think on the first day or two of first stream or two of this app, we came in here and we spent a lot of time in the WebSocket feed. So we set up to pull all the data, a WebSocket feed, and we can see it right here. So we've got a class called, I think, my WebSocket, and we've got some imports in there that we can get rid of. So is that Command-Shift-O? No, Command-Shift-L. It's one of these. So Control-Shift-A, import. And is there a cleanup imports option here? Oh, I know there's a shortcut for it. I've used it before. Okay, remove optimize imports. So whatever those keys are. And I hit enter, so you should do it, right? Optimize imports. Okay, so is that Control Command O? Or no, Alt Command O. Control O. There we go. Alt Control O. Got rid of them. Okay, so anywho, we have a WebSocket. And I suppose before we tell the story of the WebSocket, to tell the app, maybe the easiest place to start would be here in main activity. So let's just start at the top. Main activity, for the bottom navigation fragment, or it's not a fragment, for this bar down here, this is a bottom nav entry, or bottom nav view, bottom navigation view, I think is its actual name. And what we've created is a data class, which is just a pair of titles and fragments. Then we create an array of this data class, pairing titles with fragments. So super simple. And that's our bottom nav items. Then, in the app, when we create it, the first thing we do is we get connected to our WebSocket and we add it as an observer. And this is a really cool thing. So our WebSocket is a lifecycle observer. And what this means is that our WebSocket, provided that we add this line to add the observer and our activity, is able to receive callbacks when the activity has its lifecycle methods. So for example, when we want to clean up our WebSocket, we can listen for the onDestroy lifecycle event and shut down when the app is left. So we can keep our WebSocket connected and disconnected easily without polluting our main activity class. Super cool. Inside our WebSocket, so remember the first thing we do, we create the WebSocket, attach it to the activity. We set it up and add a WebSocket listener, and we send our subscribe message. And this is just from the docs. It tells you to send this message to subscribe to the WebSocket feed. Then their GDAX's service is going to start sending us a bunch of messages. And this down here, we're not skipping it. It's just, this is just the setup to get your WebSocket. So we get a client and a request, and we create the WebSocket and we connect to it using this listener right here. So we get our WebSocket, which we use the client, the request, our listener, which has all of these nice functions for us. The most important one is on message. So this is when we receive a message. And according to the docs, there are 5 different types of messages that we're concerned about. We've got open, or rather received messages for when an order is received, open messages for when an order has been received but not immediately filled. So say if you've bought something, like there's somebody selling 100 and you buy 50 of them, your order was immediately filled. It doesn't become open. So open orders are orders that stay on the books. So these orders over here are all open orders. These orders over here have been closed. So they are in the trade history. So we've got a bunch of different types of messages: received, open, done for when a message is done, match for when a match is made, and then change for when something changes. So we receive all those different types of messages, and for each of these different types of messages, we get a bunch of data. So here for a received message, it can look like this, or it can look like this. So I think the difference here is this is a market order type and this is a limit order type. So they have a little bit different data depending. Then we get open orders having different type of data, same for done and match. And change orders again can have a couple flavors here. So what we do to handle all of those messages is we create this message parser class, which whenever we receive a message, see we create it up here, with access to our database, which is statically available from the app class right here. And we create our message parser, then we use it, we grab all the messages and we call read message. And then we get the message, we decode the JSON and figure out what type of message it is. And then depending on what type of message it is, if it's a change, a done, a match, an order, open, or received, we're going to call read change message, read done message, read match, read open, read receive message, and pass in the JSON object. Then we have all of these, we pull out all the pieces of that JSON response and we put it into the database. So we created a database for each type of message using Room, and we added DAOs, which are database access objects, to give us access to the data in the database to delete it, to insert it, or just to select it. And we did that for each of the 5 types of orders. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes in here. And this one is a little more complicated. So for open orders, we just have some more questions to ask of it and some more just things we need to do to that table, because the open orders section is, its own page. So lots of data we need to get there. Just a little more going on. All right, so we get all that data, and then depending, so for example, we get a change message, we know that that means we need to change something in the open orders table because one of our orders that existed has been changed. So we need to have the ability to update orders on the open orders table. And we do that using the open orders DAO, which you have access to through our just globally available database object. And we've got a similar section for each of the 5 order types. So for example, when an order is done, we're going to delete it from the open orders section. And same thing for a matched order. We're going to make sure that that the remaining size of the so if you've bought 100 of somebody's 200 order book, there's still 100 left. So we need to decrement their order by 100. And that's what we do here. And for open messages, that's when you'd put a new one into the open orders DAO. And take heed here that we are, for those couple places where there were different things going on, we do handle that. So for example, this, some of these might not be here, so we have to handle that, if funds is not there, then we just put a blank string. And for something a little more complicated, I think thought there was one up here. Yeah, so for example, the done message might not have price in it. So you want to say, if it has price, give us the price. If it doesn't, just give us an empty string, and we'll insert a null row or null value into the database. And that gives us all of the data that we use outside of the chart data. And actually, it doesn't even give us totally all of the data. So we get all the data from the WebSocket, and what that gives us is all the new data. But unfortunately, that doesn't give us the existing data. So for example, where's the app? Over here on the order book, you know, if you're only taking new orders when you're looking at the order book, you're not really looking at much, right? Like, you need some more stuff in here. So if we just start the app up, there's going to be nothing here. You'd have to wait for a bunch of orders to come in. It wouldn't be very reflective of what's actually going on. So being able to actually show the orders and pull in the existing orders is something that's really important. And we do that using, we're going to close the data, close data section. Let's see, open orders adapter maybe. Where do we do that? View model, fragment. Because we have to need to look for what that function is called. Perhaps it's in the view model? I think that would be strange. Open orders. Where do we do it? So I know we wrote a test for it. So order book. So where does this endpoint come into play again? So Control-Shift-F, search for that, and it's going to be right here. So, okay, we do this. See, we use the app class already. So here, again, we're using the app class. So when we load the app for the very first time, what we're going to do is, and this happens even before the activity gets created, we are going to create a temp database, which then gets set as our permanent globally available DB variable. Then we're going to clear that database. We're going to download the order book, which is this call right here. So we get the order book from this API endpoint. Then we get that data with HTTP get the response string, convert it to JSON, get the pieces from that data, and add them to the open orders section. And this is going to get open orders, and then we are going to insert all of those orders into our open orders DAO, or rather open orders database. And so that's how we get all the orders that need to be in there that existed before we started the app. So remember, there's a bunch of orders that existed before we started the app, obviously, so we got to include those as well. So we get those right at the beginning of the app. And remember, app class extends application. It has the life cycle of your application, which is kind of the life cycle of your process. So when you rotate the app, not going to die. It's not going to call this recreate or this onCreate method again. It's not going to re-download the order book. And for example, we can look in here. We can look, it doesn't say download order book. I'm not seeing that all over the place. Just seeing it one time right here. So not an issue. And we did the same thing with our selected granularity and our candles. We just didn't leave the code in the app class. All right, so that's going to give us all our order book data and all of our data for the open orders fragment. So let's pop back into main activity somewhere. There we go. And let's pop in here. So this, we're using Anko to create the layout and code primarily. So we have a relative layout, which contains a coordinator layout. And the reason we have a relative layout with coordinator layout inside is that we need to have the bottom navigation view be below the coordinator layout. The issue we were having with that is on this price chart, we would have the price chart go down to here, and this view at the bottom, our bottom navigation view, would be over it. So for example, this text that you see all these nice states would be at the very bottom of the screen. You wouldn't be able to see them at all because they'd be behind this gray box. Not helpful. So that's why we've got this. And a relative layout being distinctly under the coordinator layout, or rather kind of on top of. All right, inside our coordinator layout, we've got our app bar layout, which contains the app bar, which is like the toolbar and anything that kind of fits in with the toolbar. So sometimes you've seen apps where you kind of scroll the toolbar down and it pulls the toolbar into like a bigger section. Maybe it takes a small image and turns it into a hero image, sort of a header. So inside our toolbar, then we set the title to, oh, that's not going to be right, is it? Nope, doesn't matter, because we reset the title when we call switch fragment, right? Yeah. So actually we can get rid of that line. And so we set the title text color and the background color of the toolbar. Then we set up our spinner, which we've already gone over, but we set the choices, spinner array adapter, set the adapter up, give it a color, give it an on item selected listener. And then to make sure that we're not loading data over and over, only load data if we're selecting a different position. And since this is stored and the candles are stored in our app class, they're not going to die when we rotate the app. And let's collapse spinner and toolbar. It makes this a little easier to see what's going on. So we've got coordinator layout, app bar, toolbar. Yeah, toolbar, that looks good. And then we need to call set action bar with our toolbar to set it as the action bar. Then we've got our frame layout here with ID 123, which we need the ID to be set so we can use it to attach our fragments. And we give it an app bar layout scrolling view behavior, which means that when we scroll the app, the toolbar is going to float in and out with us. Or the fragment's going to scroll and play nicely with the toolbar, which should also have an app bar layout scroll flag set. And then of course at the bottom we have our navigation view, which we're including with Anko. So whenever you want to use Anko, so it's, you know, for here it's nice that you can set properties of the view like background color or whatever else, just very, very simply color.white or whatever. You might want to be able to do that with a view that you've created in XML, and you can do that. So for here, we've created bottom navigation as a bottom navigation view in XML. Super simple. And it's going to say that it looks like that. So that is what it looks like. Yay. And we just take that. We use the includes keyword. We say what we're including, give it the ID, and then we can just keep using Anko like we've been doing. So we align it at the bottom, and we set navigation on click listener, which needs to return something, so we just have it return true. And then depending on which item was tapped, if it's the open orders ID, price chart, or trade history, we're going to switch our fragments. And then when the app starts off, we're going to switch fragment to the first one, which remember we set those up here, so that'll set it to price chart. So then calling switch fragment is going to set our current fragment ID, which we need so we can save our instance state. It's going to give us the entry, which here is the bottom nav entry. So we're grabbing that from our bottom nav items. Then we're going to do some nonsense right here. This is just total nonsense from Stack Overflow. And this is going to make it so that our price chart up there. So if we go to order book and we scroll down, see the toolbar goes away. And when we click on price chart, it comes back. And to do that, we need to have that nonsense. So this is some nonsense that scrolls the toolbar. So you see it says on nested behavior scroll, and you put it in the coordinator layout and the app bar layout, and you say scroll -100 or -1000. So that makes it scroll way up to the top. So there we go. Brings back in the toolbar. But without this stuff, if you do this and then click on price chart, it's going to be shifted up and not look good. So after we've done that, we make a fragment transaction and we call replace on our 123 ID right up here. And then we commit it. And then if it is open orders fragment, then we want to scroll the recycler view to the middle. So we scroll to position 0. And then the spinner, its visibility, we want to be set to visible only if the entry.fragment is chart fragment. So if it's chart fragment, we want to see the spinner. If it's not a chart fragment, we don't want to see the spinner. And that's how we set the spinner to disappear. See, gone, back, gone, gone, back. And we update the title to the title from our entry. And we invalidate the options menu to make sure that it gets redrawn with our new data. So it would say, for example, price chart, or trade history, or order book. All right. So that's the overarching sort of architecture for how the app is put together. From there, it breaks down to a few different sections. Of course, we've got 3 fragments. So let's look first at trade history fragment, which starts off, and we return a context. So, and when using Anko, you almost always need a context to do anything. I mean, that's true of views in particular, but you sort of get to miss that fact when you're doing views in XML. But it always requires a context to do something with a view. So first we grab our view model, which is our trade history view model, which just gives us data from our match orders DAO. So we're using our match orders database access object to keep track of all of the matched orders, and then we are watching them right here by using load match orders sync, and we load them and we observe them in our trade history fragment. And then depending on what we see, whenever we get something new, we clear our trade history adapter completely. We add in new trades, all the trades, and we notify that our data set has been changed. And then that all happens when the data updates. And so unrelated to that, you also need to set up the linear layout manager, but this is initial setup. This is more of an event listener. And also note that we take a very, very simple approach to updating our adapter. Most of the time it's not worth it to notify data range changed, or, you know, let's see, notify, yeah, you can notify moved, inserted, removed. There's all sorts of things you can say there, but in practice it's very, very easy to just call clear, add a bunch of new trades, completely refresh it, and just notify data set change. Makes it really easy. And then that is going to use view model fragment. What do we have in the adapter here? So here's the adapter for our trade history fragment. We've got a data class at the top defining what a trade is for this class. It is something that we determined, was it a buy or was it not a buy? So that's important because we need to know if it's going to make a green or a red entry. What size was it? How many were bought? What price were they bought at? And when? When did it happen? So in here, really simple, for get item count, just return whatever the trade size was. This is how I like to do my recycler view adapters, is you just have a mutable list. You just return the size of the list. Then we are including, this is our layout, completed trade right here. It's just a constraint layout. I just dragged out the pieces and mostly hit infer constraints, and that just does the magic. Then you set all the rest of the properties up. So we did all that in XML because for little pieces like that, it's just easier to get it set up here, especially if you're doing it in code, you have to kind of write it and then see what it looks like by running it. And when your app takes a little bit to run, that's not a very, very fast turnover time. A lot easier to do it that way. So we just include it like this, return that view holder and of course the view holder is just an inner class here inside our trade history adapter class. So we've got that. You find all the pieces of our view holder, and then we can update them. So we can grab a color variable, and if trade is buy, then it's green, otherwise it's red, and we can update the background color of that to green, or whatever color it is, and the text view as well to the color. And importantly here, this section, we get the size of the trade. If the trade size is bigger than 1,000, we're gonna max it at 1,000. So we're capping it at 1,000. If you've bought or sold more than 1,000 Ethereum tokens in one trade, that's gonna be maxed at 1,000 for us, because what we use that for is the width of the bar here. So these bars, little bars over here, are scaled from 0 on the left to 1,000 right over here. And that gives us some visual representation to the size. We can see here that 47 is bigger than 10 and 24 and 38 and 25. So super simple, cool to look at, and fun to do. All right, so we get all of that stuff set up. Then down here is the fun stuff where we take in the data they give us for the time and we turn it into the local time. So you'll see here, I mean, it's actually behind, but it is local time. And how we do that is they give us the time as, I think it's hours and minutes. So we grab, let's see, what do we use? We use where, yeah, so we have to get time string, which is hours colon minutes is what they give us, but it's in UTC time. So we need to get that from UTC time to local time. And to do that, first you have to get the GMT offset. Then you have to get the DST offset, so if you're on daylight savings time. So GMT offset is how offset you are from Greenwich Mean Time, so UTC time. And then the daylight savings time offset is, are you on daylight savings time or not? So then we get that time string, so we get that hour colon minute. Then we get the substring before the colon, which gives us hour. And we add to that the GMT offset and the DST offset to give us the amount of hours that it is. And then we get the minute second string, which is just whatever was after the colon. So minute, probably colon seconds, or dot seconds, or whatever they used. I don't remember. Actually, we can check. It is colon seconds. Then if the hours is less than 0, we set it to 24 plus the hours. Otherwise, we just set it equal to hours. So it can happen that your hours is less than 0 in this case. If you have added the offsets and they are negative and it's 1 o'clock, you could potentially end up at -1 hours, which doesn't make any sense. So we keep it on a 24-hour clock, which makes things easy to handle. Then we put the text as hours colon minutes seconds. Super simple. After it's all done. All right, so that's our trade history section. If we pop back, take a look, we can see got the size as a text view, which is right aligned. Can we show that as well? History adapter. So here we get some formatting to get these the right width and decimal places. And I think this is from the app class, yes? No, this is from the extensions class where we put functions that just functions that need to be generally available. So like I've got height pixels as something you can just access off of a context object. So really super simple. Lots of fun. All right, so got that. Let's look at another one of the pages in here. And actually, let me pop into, been doing a lot of talking. Let's see if there's any comments on that. Actually used to have real-time data. We are not using multi-threading yet. We are using a WebSocket. And it works okay. I think it has a little bit of issues that are not necessarily our fault on days like today where it's just busy. So for example, we've had this running for a little bit and now it's 9 minutes behind, so it's not so good. But they have partially degraded service, so I'm not sure that that's our fault. And let's come back in here. So let's look at what we just looked at trade history. Let's look at order book. That was the next one we worked on. So order book, we come into the fragment, just like the last fragment. Starts off with a recycler view that we get off the context object. We set up the layout manager for that, set the layout manager, and the real important bit is that you have a view model for it, and we use that view model. And we have an update count variable, which, yes, so the update count variable there tells us whenever this gets updated. So whenever this is called, this is going to be, or updated, whenever we're observing something, it's going to be more than 1. But when we come into this variable for the first time, we want to scroll to position with offset to half height. And what this does is it makes it so that when we come to the order book and it starts in the middle, which is perfect. So it lets us scroll around in there rather than starting at the bottom or starting at the very top, which wouldn't be very useful. It starts us in the middle of the order book, which is very useful. Oops. So, Actually, let's just hit run again to get it to come back up. And that gives us the open orders fragment. And in here, we grab, this is kind of some cool code right here. We have our bids. So here it is a list of price side tuples. Now price side tuple is from, I think it's from right here, open orders DAO. Let's see. Yeah, you have to define, if you want to return something other than just one thing, you need to define what your tuple is. So here we have a price side tuple, which takes a price side and has a sum. So how many are you doing? And that's something that we can return from one of these queries. So we get those objects, and that's what we get here. So we're going to filter these, and we're going to take only the ones that have a buy for the side, and we're going to sort those descending and take 100 of them. So we're going to sort those descending. So we're going to have the highest buys at the top, and we're going to go like this and take 100 of them. Then we're going to get the asks, which are the ones who are trying to sell, and we're going to sort those by price, and those are going to be sorted ascending. So it'll be from the lowest sell offers to the highest sell offers, and we'll take 100 of those, and then we add all the asks reversed and all the bids. So we get them like this, we put them together, and then we add all of that. So this list here, we add that to our open orders and the open orders adapter, which is just the array or list of price side tuples that we have in there. So we've got our buys down here, we've got our sells up here, we put them together into one list, and then we add them to this open orders array, which I'll call it an array, why not? And then here we use the same completed trade view that we saw earlier, and we update it using some different parameters. So we grab the pieces we need, we update the colors based on what side it is, so buy or sell. We set the max size width, and this is going to be used to set the view width of the sidebar. So just like we did, oops, somehow we had an error. Did I change anything on that? Oh, I hope I didn't drag something around, you know, accidentally like that. That'll always screw you up. Should undo that one. So yeah, that'll set the view width, and that'll give us the bars we want. And we'll format the number strings and the price text. And that'll be the open orders adapter. There we go, price chart, yay. There's the order book, starts right about in the middle. It's not always perfect, but it's usually pretty close. And cool, so we got all that. That's open orders adapter. Let's look at, so we got through to adapter, then let's look at chart fragment. So chart fragment's the other fragment we can show, and all it does is show a chart view, which currently we're not using for anything, so we can instead just return, actually no, we shouldn't just return chart view because well, we'll just leave it, it's not hurting anything. But late init here is a way to initialize a variable without needing to set it equal to something. However, you will run into issues if you access a late initted variable without setting it. So this is one way we can kind of get around not being able to set stuff up because of onCreateView. So for example, in I think main activity, we probably do this. We have a bunch of late init view variables. These are all different view variables, and you can't initialize your view variables up here because you need a context to initialize your view variable, and you don't have a context until onCreate. So by using a late init, we can get around Kotlin's requirement that all variables be initialized, and you know, as long as we make sure to initialize them down here, which we do. So back in chart fragment, that's what we're doing there. We just set it equal to a chart view, and in chart view, we get some paints, green paint, red paint, white paint. We define a candle object, which has a time that the candle occurs, the low for that time period, the high for the time period, the open, so where did the price start, and the close, where the price ended. And last, the volume, which is how much trading happened during that time period. So remember, a candle represents maybe a 3-hour time period or a 6-hour, or I guess in our case, it's 15 minutes an hour, 6 hours a day. Is that what we did? Let's see. It is hiding and toolbar in the spinner. Yeah, 15 an hour, 6 hours a day. Yep. So back into chart view. Those are the choices. So in the init, which in Kotlin, this is like your constructor. So this is the first thing called is this init block. We set the green paint. So these are just blank paints until we call called init and set it to a green paint. And we set the green paint to be a stroke style instead of a fill. And what that means is that this bit right here is going to be, see how the green boxes are not filled in and the red boxes are filled in. So that's because this is a stroke and the others default to fill. So we have a red color, red paint is going to have a fill. And we give them a nice stroke width so that we can actually see them. So if you had that to say maybe 1 stroke width, it just look like little wispy nothings. Be kind of an annoying chart to look at. And we set for the white paint, since that's used for text, we want to set it to white and then give it a text size. All right, then we've got our candles variable, which is from the app class right here. So when the app first starts, this is going to be set to an empty list of candles. And then, oops, all right, then we have our candles, and we call, if candles is empty, we're going to call reset candles to 15 minutes because that's what the first selector in the spinner is. So that's what the spinner starts at. And we get our endpoint, make our API call, and then with the data, we're going to first do some cleaning of it. So it comes with, all the little data pieces have these 2 brackets before or after it. So nice to get rid of that. Then from those, we split the data on that to give us a list of pieces. So it comes in as a string. Then we remove some of the parts of the string we don't need. Then we split the string based on what separates each item. So each item here is separated by a bracket, comma, bracket. So then when we split it like that, we get an array of those items instead of them as a string. Then from that array, we map each item to a candle. And so we take the item in the array, which each item in the array is a candle, and we split that item by commas, which then gives us another array, except this array now contains the time, the open, the close, the high, the low, and the volume. And so we create a candle with that. And then that turns into a list by calling toMutableList. So we start with a string. Then we split that string to give us an array of candles. Then we map that on each candle to a list of candles, which gives us our candles. Then we invalidate the UI, and invalidating the UI tells it that it needs to draw itself again. So it needs to update, and that's going to trigger a call to onDraw. So it's going to call onDraw at the very beginning when this view is first created. It's going to call onDraw to see how it should draw itself. But at that point, when this is first created, so right after init, there's not going to be, you're not going to have heard back from the API yet. So it's going to have no candles and not draw anything, which is why it's important that after we have our candles, we call invalidate to say, you know what, we have our data now, time to draw. So then we'll come in here and we'll have, and I do this sometimes to help remember the order of things in an array. So here candles go, each candle is time, low, high, open, close, volume is what's in there. And what's nice actually is that it's not an array, it's an object. So you can just hit dot to figure out what these are. I might not even need this as a comment. But so it won't be empty, and we're only going to take 60 of them, the most recent 60. And the reason for that is that there's 60 on this screen. So just matching this screen keeps things really simple. And then we need to get the real height. So we set our height of the bottom navigation view to 56 dp. So since this just floats, the bottom navigation view just floats on top of the view behind it, we need to shift our view up by that amount to make sure. So we could draw down here if we wanted to, but nobody would ever see it because the bottom navigation view is in front. So we draw up here, and so we set that as sort of the real height. So the real height is from here to here. So we get that variable. We get the width, which is the width of the canvas. So canvas here being this whole space. We get that width minus 100 because we need room for our text over here to show the price. And then we get the highest price and the lowest price by getting the max by the high and the min by the where did we end up? And the min by, so this is going to give us the minimum of our subcandles depending on the low of a particular subcandle, and we're going to get that subcandle's low. So this will just give us the lowest price out of any of our candles. This will give us the highest price out of any of our candles, and we can use that data to make sure that, see, we've got the highest at the top and the lowest at the bottom. So make sure that it just fits nicely in our window. And then we've got a function called scaled height, which is just going to scale. So it gives us, so that we can pass in a price, and it'll tell us where the height should be on our graphs. That makes it easy for us to just plot points. So this sort of transforms price into position or of the y-axis on the screen, so that we don't have to think about it too much. So if you see here, it takes the price minus lowest price divided by highest price minus lowest price, and then times it by the real height to get where it should fall, and then real height minus that, because the y-axis on an Android device and most devices in computers in general is reversed, so the y direction goes from top to bottom positive instead of bottom to top like you're used to with graph paper. Then we have a draw candles function that takes each subcandle, figures out the dimensions of the candle, where it should go, figures out what colored paint we're going to need to use, and it's going to draw the candle. So we're going to draw a rectangle for the body of the candle, and we're going to draw a line from the bottom, or from the midpoint to the top, and we're going to draw a line from the midpoint to the bottom to give us the full candle. And depending on if the candle's index is modulus 12 equals 11, or if its index is 0, we're going to draw the date string. So what this means is that, so if we just did modulus 12 equals 0, we would only draw, I think, this one, this one, this one, this one, and this one. So we'd be leaving one out. So by having or here, we're able to draw one extra. So we get this one right here as well, or this one, I can't remember which, but this lets us have a fuller range of dates on the bottom. And we get the date string, and we just call draw text and tell it where to go, which is these positions. And we can see if we come into this function, it's what text you want to draw, where is it, X and Y, and then what kind of paint you want to use, which is white paint. Then we've got a function called draw price labels, which draws these price labels up the right hand side. So we don't have a separate function to draw the date labels, just because while we're looping through the candles, it's pretty easy to draw these at the bottom as well. So we just hit those while we're looping through. So draw candles, draw price labels. Then at the bottom of the function, we just call draw candles, then call draw price labels. And that's how you draw the chart. Then we've got our get date function down here, which gets the date for a specific time. And this time here is going to be in seconds, which is not what we're used to dealing with. So normally we're used to having our epoch time in milliseconds, which is why we convert it to, time times 1000 right here. And then we convert that to a date format, and that's how we get this right at the bottom. So see, MMM gives us sep or aug if we go out to 1 day, or Jill. And then just D gives us that right next to it. So this is our formatting, gives us the month, space, day, and kind of this way, which is similar to how they do it. Though if we look at the app, there's in like the 15-minute interval, we are not keeping it any prettier than that. So we don't do, this isn't quite as useful saying September 14th, September 14th, and September 14th, and so on. Not quite as useful as they've got, but again, we're not shooting for perfection here. We're shooting for pretty good, and I think we're there. So I think that brings us to the end. Let's look at the XCS function, see if we're missing anything in here. Got a extension value to get the width of the pixels and the height in pixels. We've got some colors just available. So by defining them out here in this file. This isn't in any class, this is just available to everywhere. We can just type green and have access to this color. Same with red and our primary color and our primary color light. Here we have an extension function on any object, which lets us call E anywhere, and it just logs a message. We've been using this function all over the place. It logs the simple name of the Java class from where we're logging the message, gives us our tilde, or rather backtick tilde, which makes it really easy to find in the log cat. And then see here, we've got all these chart views. So this is calling from chart view. This is calling from a recycler view. And we can just see all these nice log messages. And it's super easy. You just have to use E and put something in between the parentheses. And we've got our two format functions here, format size string and format num string. And I think that's about it. I think in addition to that, we've got a couple tests. We had to declare spinner items, got that covered. Don't think we did anything with styles really. We set them just to have them set, but that's about it. We're not going to put in a launcher icon. That's a pretty simple thing to do after the fact. And what did we use? Oh yeah, we've got, wait, we're not using this menu, are we? Let's see, Command B. Find usages. Bottom navigation. Oh, we are using that. Interesting. Okay. Oh, right, because we need these IDs we use from this bottom navigation items that goes into our bottom navigation layout view right here. Where did they go? Bottom navigation items goes into that layout view, goes into main activity down in right here. We can use those IDs to determine which fragment to switch to. So those are important. And yeah, I think that covers the whole app. See trade history, price chart, order book, see if there's any questions. Perfect. So yeah, that's the app. Let's look at it one more time. Check it out next to the thing. Next to what we're trying to do here. So we've got our order book. They've got their order book. Ours is a little out of date, of course. I think that'll be clear if we go over the trade history. Yeah, we're about 5 minutes behind. So things aren't quite keeping track. But remember, they've got degraded service today. So all right, looks good. Thanks for joining me on this journey to create the app, and I hope you found something really helpful here. I think my biggest takeaway from working on this project has been how wonderful using the Room API is. So if anything to take away from this, it's that if you want to store data using SQL and Android, there's no better way to do it using Room right now. It's super simple, and just makes things really easy. You make a class, you talk about how you should access that class, and you got to make one of these guys too. They've got it all packed out in the Room articles in the Android documentation. They walk you right through it. Really easy to do. That's probably my favorite part of the project. I think it's super cool that we used a WebSocket too. This is fun that we get to have data coming in very quickly and handle that data. We've got a couple of other data points that we're pulling in through APIs, such as the open orders data as well as the price chart, which the price chart looks great. And yeah, I think that's a pretty good place to end it. Thanks for watching, and I'll catch you later.